Welcome to our deep dive into interesting topics.
Great to be here.
Today we're diving into a really fascinating essay by Jörg-Owe. It explores the world of supercritical carbon dioxide.
CO₂, yeah.
Exactly, CO₂. And its potential to, well, maybe revolutionize textile finishing.
It's got huge potential.
So if you've ever wondered how we can make the clothes industry greener, but, keep the quality high, this is definitely for you.
Absolutely.
Our goal today is pretty straightforward. Pull out the key insights from Schneppat's work, make this cutting-edge tech clear, engaging.
Let's do it.
So maybe let's kick things off by understanding why we even need this innovation. What are the fundamental problems with how we currently dye fabrics?
Well, the traditional way, historically, it's relied very, very heavily on water.
Right, lots of water.
Yeah, tons. And the core issue there is that this process generates just significant amounts of colored wastewater. And when that gets discharged into ecosystems, it can cause, well, serious harm. You think of rivers carrying these vibrant but often toxic dyes. That's the reality.
Yeah, those images, they're hard to forget. And it's not just the water volume, is it? There are other environmental headaches baked into the old methods.
Oh, absolutely. Conventional dyeing also uses a whole cocktail of auxiliary chemicals.
Like what?
Things like fixatives, salts, stuff designed to help the dye actually bond with the fabric.
Got it.
But these chemicals, they just add to the pollution problem and the overall waste footprint of the whole industry.
So Schneppat's essay brings in supercritical carbon dioxide, CO₂, as this potential game changer. What actually is this stuff? What makes it such a promising, sustainable alternative?
Okay, so CO₂ tech, it offers a genuinely innovative, sustainable path. We could call it waterless dyeing and finishing.
Waterless.
Essentially, you take carbon dioxide, the same stuff in fizzy drinks, and you heat it and pressurize it way beyond a specific point, its critical point.
And what happens then?
Well, that transforms the CO₂. It gets this unique combo of properties. It becomes dense like a liquid, so it can dissolve things.
Like dyes.
Exactly, like dyes. But it also keeps the mobility and sort of penetrating power of a gas.
Huh. So it's like this liquid-gas hybrid.
Yeah.
How does that help us dye clothes without all the water?
Precisely. Because it has that gas-like mobility, CCO2 can wiggle its way into the complex structure of textile fibers much more effectively than, say, liquid solvents in water.
Okay.
Think of the CCO2 almost like a supermobile delivery van. It carries the dye directly into the tiny nooks and crannies within synthetic fibers, way more efficient than trying to float dyes in gallons of water.
Right. So it gets the dye in there without water as the carrier.
That's the key. It allows the dye to penetrate really deep into the material. No water needed for that transport job.
Okay, the waterless part makes a lot more sense now. But what's the actual mechanism? How does the CCO2 make the dye stick?
Well, what's really neat is that CCO2 is actually a pretty powerful solvent for a whole range of dyes. And it seems to have this particular affinity, this liking, for interacting with synthetic fibers like polyester.
Okay.
And that interaction helps transfer the dye into the fiber structure. You get vibrant colors, and sometimes it can even enhance certain fabric qualities.
Interesting.
Plus, researchers have worked out some clever pre-treatment tricks. They treat fabrics with concentrated dye solutions before putting them in the CCO2.
And that helps how?
It significantly improves how evenly the color spreads and how deep the dye actually penetrates. Better results, basically.
And I guess if the dye penetrates better, that has a knock-on effect, right? Less rinsing needed afterwards.
Exactly. Because the dye is driven so effectively into the fibers by the CCO2, the need for loads of washing steps after dyeing is often, minimized, sometimes even eliminated completely.
Which saves even more water and energy.
Bingo! Makes the whole process leaner, cleaner.
So, Schneppat's essay points out several key areas where CC2 tech can really make a difference in textile finishing. We've hit waterless dyeing, but what are some other big applications?
Well, beyond just getting rid of wastewater, using CCO2 drastically cuts down our reliance on those auxiliary chemicals we mentioned.
The fixatives and salts?
Yeah, those. So that directly means less pollution, a smaller waste stream. Plus, CO2 itself, it's non-toxic, non-flammable, safer for workers, too.
Okay, that's a good point. And what about energy? Does shifting to CCO2 save energy, too?
Absolutely. CCO2 dyeing generally tends to be more energy efficient than the traditional ways. Couple of key reasons.
Go on.
First, it often runs at lower temperatures. We're talking maybe 35 degrees to 50 degrees C, which is quite low for dyeing.
Right.
And second, maybe even more significantly, it completely gets rid of the need for that really energy-hungry drying phase. You know, the one that's essential after water-based dyeing.
Oh, yeah. Drying textiles takes a massive amount of energy. Cutting that out is huge.
It's a major plus. And Schnepphat also mentions the economic side, especially the idea of recycling the dye and the CO2.
Recycling them? How does that work?
Yes, this is a crucial advantage both for the planet and the profit margin. Both the CO2 used in the process and any leftover dye that didn't bond can be pretty effectively recovered.
And reused.
And reused in the next dyeing cycle. It's like a closed loop system.
Nice.
So you reduce how much raw material you need, you minimize waste disposal, leads to cost savings and a lower environmental hit.
So the environmental advantages are really stacking up, aren't they? Less water, fewer harsh chemicals, lower energy demand, potential for reuse. It sounds like a really significant step forward.
Yeah, if you look at the bigger picture, this tech isn't just about a slightly greener process. It's potentially about rethinking textile dyeing completely, taking it from something highly polluting and resource heavy
to something much lighter on the environment.
Exactly. We're talking shorter processing times, maybe a smaller carbon footprint because you're not heating water, drying fabric, treating wastewater, and a better E-factor.
E-factor.
Yeah, it's a measure of waste produced per unit of product. CCO2 systems tend to have much lower, much better E-factors.
Okay, this all sounds incredibly compelling.
Mm-hmm.
So why isn't CCO2 technology like the industry standard already? Schnepphat's essay also digs into the economics, and it sounds like there's some pretty big hurdles.
That's a really crucial point. While CCO2 can be cost-effective in the long run, I mean, CO2 is relatively cheap, non-toxic, and you save on waste management energy.
Yeah.
But the initial capital investment, the cost of setting up these new processing facilities, that can be substantial, really substantial.
The classic problem with rolling out any new tech, the upfront cost.
Exactly that. Manufacturers often have to bear these big upfront costs, and sometimes they don't have guaranteed purchase agreements from the big brands.
Creating uncertainty.
Right. Makes them hesitant to take the financial risk. There's often this disconnect in incentives right across the supply chain. Brands might talk up sustainability.
But the manufacturers foot the bill for the new machines.
Pretty much. They're the ones making the big capital outlays, sometimes without that solid commitment.
That makes total sense. Kind of a standoff, isn't it? Brands want the green product, but manufacturers are cautious about investing without guaranteed orders. What other roadblocks does Schnepphat highlight?
Well, performance is always key. You have to ensure that textiles dyed with CCO2 meet the same tough performance standards people expect. Color fastness, durability, all that.
And is it?
Generally, yes, but there can sometimes be subtle differences in the feel of the fabric. The hand feel is the industry term. That might need some fine-tuning, some optimization of the CCO2 process.
Okay. And it sounds like companies also face a big strategic choice. Tweak the old ways or jump into something totally new like CCO2.
Precisely. Brands and manufacturers, they have to weigh things up. Do they make small incremental improvements to their existing water-based processes? Or do they take the bigger leap towards a disruptive tech like CCO2?
Which offers bigger benefits but also bigger risks.
Exactly. CCO2 has potentially much greater long-term advantages, environmentally and maybe economically, but it definitely comes with higher initial risk and means moving further away from how things have always been done.
The essay also touches on regulations. Are there specific compliance hurdles for CCO2?
Yeah, I mean, even though CCO2 is seen as environmentally better, any new industrial process still has to meet pretty strict environmental performance and safety rules.
Yeah.
Things like ZDHC, that's the Zero Discharge of Hazardous Chemicals Program, or REACH, the big EU chemical regulation. Getting through those regulatory hoops can add another layer of complexity and cost to adoption.
It's definitely not simple. But it's not all about obstacles, is it?
Yeah.
Schnepphat's essay also points to some really exciting recent innovations that are tackling these challenges. What's new and promising?
Yeah, what's really encouraging are the advances coming from companies like ECO2 dye technology and Devon Supercriticals.
Okay, what are they doing?
Well, ECO2 dye, they've developed specialized tech for dyeing yarns and threads using CCO2, but they've made it work with conventional dyes, ones that are compatible with the CCO2 environment.
So using existing dye types.
Some existing types, yeah. And they're really pushing on CO2 recycling, making that loop tighter. Plus, they're looking into using CCO2 for other steps like like pre-treatment scouring and even stripping dyes off waste textiles.
Wow, okay.
Their tech seems particularly effective for polyester and wool right now.
That sounds like it's hitting the recycling angle and maybe broadening the material options. What about Devon Supercriticals? What's their approach?
Devon Supercriticals uses a slightly different tactic. They focus on pre-coating the fabrics.
Pre-coating. With what?
With the dyes and maybe other chemicals needed, basically preparing the fabric so the dyes dissolve better in the CCO2.
Oh.
This approach might let them work with a wider range of traditional dyes, and importantly, more materials including cotton and blends.
Cotton's been tricky for CCO2, hasn't it?
Historically, yes. Natural fibers like cotton have been more challenging. So Devon's pre-coating method is interesting because it tackles that directly. It sort of preps the cotton fibers to be more receptive to the dye within the CCO2.
So streamlining the process and maybe opening it up to more fabrics.
That seems to be the goal. Streamlining, reducing water, reducing chemicals, broadening applicability.
These innovations definitely sound like real progress, tackling some of those limitations we talked about. Okay, so let's try and bring this all together. Thinking about the bigger environmental picture and the future for CCO2 in textiles, based on Schneppat's work.
Right. If we connect it all back to that critical issue, sustainability, the potential for CCO2 to seriously reduce the textile industry's ecological footprint is, well, immense.
The savings in energy, water, chemicals.
Exactly. It all adds up. Directly contributes to lowering the industry's global warming potential. But, as Schneppat also points out, there's still work to do. Ongoing R&D is vital.
Especially for certain fibers.
Particularly for optimizing how well natural fibers, like cotton, work with CCO2 dyeing. That might mean finding new ways to fix the dyes, new fixing mechanisms, or maybe even looking at slightly altering the fibers themselves.
So as we've explored in this deep dive, looking through the lens of Jörg-Owe Schneppat's essay, supercritical carbon dioxide technology really does offer a compelling vision for a more sustainable future in textiles.
Yeah, from wiping out massive amounts of wastewater to drastically cutting the need for harmful chemicals, improving energy efficiency, the potential benefits are genuinely transformative.
They really are. And while, there are definitely challenges to sort out, especially that initial investment cost and the whole complexity of shifting supply chains.
For sure. Those are real.
The exciting innovations being pushed forward by companies like ECO2 Dye and Devon Supercriticals, they give us a real tangible glimpse into a cleaner, maybe more responsible way to make our clothes.
It's a promising path forward, definitely.
It really makes you wonder, doesn't it, how quickly advancements like these can actually get adopted more widely. And thinking bigger, what other industries might be just, ripe for this kind of revolutionary resource-saving approach?
That's a great question to ponder.
Thanks for joining us for this deep dive into the insightful work of Jörg-Owe Schneppat.